All right, so let's talk about temperature. Zero on the Kelvin scale is called absolute zero, which is nature's lowest temperature. They say all molecular motion said to stop really, it probably reaches some minimum non-zero value. Science in most of the world uses the Celsius scale, and it's more convenient in that the 0 point shifted 273, really 273.15, but we'll kind of round off. And so the Kelvin temperature is equal to the Celsius temperature plus 273. The Fahrenheit scale, which is commonly used in the United States, is not used in science. For comparison, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit, where water freezes at 0 and boils at 100 on the Celsius scale. We can interconvert the two. Degrees Celsius equals the quantity of degrees Fahrenheit minus 32 divided by 1.8, or degrees Fahrenheit equals 1.8 times degrees Celsius plus 32. Personally, I like the Fahrenheit one because it looks more like the equation of a straight line, easier to remember. And these two equations are just really algebraic rearrangements of one another. And so that makes it an easy way to remember. Here's a comparison of the three scales. You can kind of see where the equations come from. On the Kelvin scale, water freezes at 273, boils at 373, 100 degrees between the two. Same as the Celsius, where it freezes at 0 and boils at 100. So the size of the degree is the same, just the 0 point is shifted. On the Fahrenheit scale, water freezes at 32 and boils at 212. There's 180 degrees. That's where the 1.8 in the Fahrenheit to Celsius comes from. Some conversions use the 9/5 and 5/9. I find people have trouble remembering that version of the equation, but if you've already learned it and want to use it, be my guest. And then I put normal body temperature, 98.6 Fahrenheit is about 37 degrees Celsius, which is about 310 Kelvin. And you can see that the plus or minus 32 in the equation comes from the fact that the Celsius and the Fahrenheit, the 0 point is shifted 32 degrees. Now we're going to use that, and we're actually going to convert 25 degrees Celsius, which is room temperature, and a lot of scientific measurements, to both Fahrenheit and Kelvin to practice our unit conversions there. Okay, so let's look at this problem. So if we want to convert 25 degrees Celsius to Fahrenheit, we've got our formula, which I copied from the notes down here. So all we really got to do is plug and chug. So we're going to say 1.8. We're going to plug in 25 degrees Celsius plus 32. And that's going to work out to be 77 degrees Fahrenheit when you run it through your calculator. So that's your answer to this part. Now, I think they choose 25 degrees Celsius perhaps in part because if you do that conversion, you realize I didn't round that number off at all. It is an even conversion. It comes out to be precisely 77 with no long stringy decimals. And so I think since that's an even conversion between the two scales, they pick it for room temperature. Personally, 77 is a little too hot for my room preferences, but it is an even conversion, and a lot of labs are kept at that temperature because of that. Now, if we want to convert it to Kelvin, 25 degrees Celsius plus 273. And that's going to work at about 298 Kelvin. And that would be your answer for the other. Occasionally you'll see somebody call 300 Kelvin room temperature. They're just rounding off, so don't really just take it personally.